to the next slide, and what we're looking at are all the different renewable energy technologies. Now, there are lots of renewable technologies. There's solar PV, concentrated solar PV, slight variation on the flat panels you see in the first screen. There's solar thermal. That's an example of a parabolic trough solar thermal, but there are other alternatives, including what are called the power towers, which are the very tall towers surrounded by fields of mirrors. There's geothermal. That's probably taken from somewhere in Iceland or something like that, where it takes advantage of volcanic activity on the surface to produce the heat to run geothermal power. But there are other alternatives involving drilling deep wells to either take advantage of hot water in aquifers. In fact, there was a small geothermal power plant in Birdsville that's been running for many decades. It's pulling hot water out of the Great Artesian Basin, and now that there's also the more interesting engineered or enhanced geothermal, which is very deep wells down into beds of granite that could be up to 5 kilometres underground, and then that granite is hydraulically fractured so that water can pass through the granite from one borehole to another borehole, and in passing through the granite it gets heated up and used to run a power generator on the surface. And Australia has been taking a lead in geothermal, and there have been a number of quite interesting pilot plants, particularly in the Cooper Basin in South Australia, looking at engineered geothermal. Another one, of course, is wind, a very well established technology, and I'm sure everyone's seen onshore wind turbines. This is an example of an offshore wind turbine, very popular in Europe because Europe doesn't have as much vacant land as Australia does, and also the North Sea is quite shallow, so it's quite easy to put offshore wind turbine. It's less relevant to Australia because firstly we've got much more land, and secondly our continental shelf is quite small, and particularly if you go down to the southern coast of Australia, which is where the best national wind resources are, that also hits the roaring 40s and the 50s. So it's very violent, very violent sea. So you've got additional challenges with wind turbines in that part of the ocean. Final one is biomass, which looks at either, in this case, burning, I think that's probably the gas, cane fibre at sugar mills, burning it in a boiler. So there are, and the final one is marine power, which looks at either using waves or using tides to generate water flow, or to take advantage of water flow to generate electricity. And there's a very interesting application of wave power currently in Western Australia near Fremantle. There's a company called Carnegie Marine Power, and they are doing some very clever work on marine power, and they've actually installed a wave power generator that's supplying a little bit of power to the naval base, HMAS Stirling, at Garden Island in Western Australia. So it's quite an innovative use of the electricity from a marine power generator as well. But one thing is, you only lots of options, but you only really need to worry about three. Only three matter to you as small business operator or small to medium business operators, and that's solar thermal. So that solar thermal ranges from the traditional solar hot water heaters that are on an awful lot of house roofs through right up to the to those power towers that I mentioned earlier, which are used for utility scale power generation, which could be generating or heating fluids up to 1,000 degrees. Solar hot water heaters are very, very cost effective in most cases, particularly if they're displacing electric immersion hot water heaters, and it's an extremely established technology. Australia was one of the leaders in solar hot water with the company Solar Heart, which has been around for decades, very well established. The more interesting ones, I said, there are things called parallel troughs and linear Fresnel lenses, and one of the earlier slides, pictures that in that earlier slide showed the parallel trough, because they're very good at heating water or other fluids to about 300 degrees or slightly more. So if you've got a requirement for hot water for cleaning, or so, if you're a meat processor, you've got to do rendering or something like that, where you need heat in the 200 to 300 degree range, then something like a parallel trough or a linear Fresnel lens collector could be quite useful. The next one is the ubiquitous flat panel solar PV, which directly convert sunlight into electricity, and as you connect arrays of them together, you can end up generating an awful lot of power. Like an example that I just saw yesterday, because we were doing a bit of research into it, is that the US Department of Defense is going into renewable energy in a very, very big way, and they've got a number of very large facilities in the western deserts of the United States, and one of those facilities they're looking at putting in a 500 megawatt solar power station, all based on solar PV. Their efficiencies in terms of how well they convert sunlight into electricity are quite low at 20%, but that's not such an issue when you've got such a large amount of energy coming in the form of sunlight. And now what's key to them and why they're applicable to small to medium businesses in the food and grocery sector is that they are first very good for standalone power, and secondly for small scale power generation. Because solar, particularly on the latter point, solar PV is one of the few power generation technology that scales down very, very well, so that you get as much efficiency, and particularly if, or say kilowatt hours per dollar invested in it, of a set of panels on your roof as the 500 megawatts worth of panels that will go into the deserts in western United States. It scales very well, and that's why you see so many small systems on roofs. And more importantly, they have become sufficiently cheap that if they are displacing power that you'd otherwise have to purchase, then you'll find that they're cost effective as well, and you don't really need any government subsidies to get value out of solar PV. We'll talk more about that a little later on. The third technology that's of real interest to your sector is their biomass, and what I've got there is anaerobic digestion. So anytime you've got available organic material, in this case it's a wood fibre product or plant fibre product of some sort, or it's just a liquid with a lot of organics in it or something like that, you can use that to turn it into energy. In this case, it's burning it in a conventional boiler to produce heat for steam or something like that, and the likes of pulp and paper mills and sugar refineries have been doing that for ages. Or if you've got other organic streams, you can consider some of the more exotic forms of bioenergy, and the one I'm talking about there is anaerobic digestion, and that's if you allow certain types of bacteria to attack organic material in the absence of oxygen, in the absence of air. It produces a stuff called, which is referred to as biogas, that's about 50% methane, so it can be used as a fuel. That's anaerobic digestion. There are also alternatives, emerging technologies called pyrolysis and gasification, which heat the biomass very quickly, either in the absence of oxygen or with oxygen there, and turn it into either a gas or liquid fuel. And they can be done quite successfully at small scale, and an awful lot of food facilities such as dairies, piggeries, things like that, particularly in Europe, will have anaerobic digestion facilities to produce biogas, which they then use to raise steam or generate electricity. Now, the final slide I've got in this series is not so much a type of or a source of renewable energy, but it's starting to talk about energy storage and in particular batteries, because due to firstly the work that's being done on electric vehicles, and also recognizing one of the challenges with renewables is that they're not entirely consistent, that they're not all there all the time, that you need ways of storing that energy to use when the demand is there. And what we're now seeing is the emergence of low-cost batteries for energy storage. Not quite there yet, but over the next few years, we expect to see more and more batteries being used, and particularly to couple up with solar PV systems so that you can capture